So we're looking at Coulomb's law. Right now you should have these notes printed in front of you. We're talking about Coulomb's law. You should read this section and then we come up to the example here. In the end, the formula Coulomb finally came up with, okay, could be used to calculate the force between any two charges separated by a distance. So the electric force is equal to K, which is some constant called 8.99 times 10 to the 9 Newton meters per coulombs. And that is then going to get, sorry, that is not squared, that's here. This is a constant. It should be on your formula sheet, not something you have to memorize. Okay, we have Q1, which is the charge, the second charge, and then we divide that by the distance between the two charges, and that is in meters. So this is Newton's meter squared per Coulomb squared. Okay, so that is the first thing you have to write down. Then it goes on and it talks a little bit about each of those quantities. Okay, we have to be careful positive and negative values. Okay, so example number 1 is the next thing we're going to look with this comb and the hair. A comb with -2 microcoulombs of charge is 0.15 to the left from a hair with 3 microcoulombs of charge. Determine the force that the hair exerts on the comb. So the force, I have my formula. I'm going to put my K value, which is a constant, something you can always find. We're going to multiply by the charges, the two charges. A microcoulomb is 10 to the -6 coulombs. So we have 2 microcoulombs times 3 microcoulombs, so those are our 2Q values, divided by the distance in between it. It's 0.15 meters squared. So I'd like you to enter this in your calculator. Notice the units. Newton's meter squared per Coulomb squared. Here I have meter squared. In my denominator, I also have meter squared. Those will cancel out. Divided by Coulomb squared, and it's coulombs times coulombs. So those are going to cancel out as well. I'm just going to be left with newtons, which makes sense for a force. So pause this video, put it in your calculator until you get the answer. So hopefully you get the same answer as me, which is 2.4 newtons. Because it's positive, it's going to be to the right. Sorry, because we have a positive and a negative, it's going to be to the right. The force the hair exerts on the comb, they're going to attract one another. It's going to pull it towards the right.